Hello, everybody. Welcome to today's live stream. My name is Angelo, and on the keyboard I have my good buddy and colleague, Brad Tallis. All right, so I'm just making sure that you guys hear me okay. Brad said it sounds good. All right, great. Thanks, Brad, for being my wingman and letting me know that. Sometimes when we do these live streams, no matter how much we prepare, sometimes technology surprises us. So thanks, Brad, for letting me know that it's working. Everybody's joining us. Thank you all for being here and being part of our day. We appreciate the opportunity, and it's a privilege for us to be here. So we are going to be talking about secondary operations. So I've got a part here that I've done. I've showed it before. And this is a part that I designed in Fusion and made in Fusion. I'm going to show you a quick workflow on this one. And then we've got a second part that we're actually going to go through and program step by step. It's has a lot less features than this guy, but I'm going to show you how the secondary ops work with this one. And then we'll go, like I said, on to another one that I think is will expose you to a work holding technique. There's more than one way to hold things, but we will be showing you another way. So let me switch my screen here. And of course, if you guys have any questions, drop them in the chat there. Mr. Brad Tallis will let me know, and I'll try to look out for those and answer those as they come. Okay, so we've got this. This is a design I did for a trade show I did for Haas Automation. Did it on a 5-axis machine. I have some video of this being machined. In fact, even some 5-axis motion on my Instagram. Had I thought about it sooner, I would have queued that up and showed you some of the video of it being machined. Towards the end, I can look for that. I don't want to waste too much time on that. So one way, so before we have a feature now in Fusion called Continue Rest Machining, and it's a preview. So go to the top right hand corner of Fusion and you're gonna look under Preferences, and then when this box pops up, I want you to go here to Preview Features and look for, I'm just gonna type Continue. So I'm going to do a search for Continue. It's under Manufacture. You want to enable this, Continue Rest Machining for Milling. So this is in preview. It's still being tested, and it's only for milling. Obviously, turning will come later on. So make sure you turn this on. It will expose some new functionality, and I'm just going to hit Cancel here. And then, when you're in the manufacture side, you need to come here to Utilities and turn this on, this checkbox. So it's under Actions, right? So hit that little green button to turn it on. If that's not turned on, you won't get this to work. Okay, so again, to recap, you go to your name or initials or your little icon there in the top right, go to Preferences, navigate to Preview Features, and you can scroll down or you can just type in a search here, and I typed Continue and enable this. You'll hit OK. I'm just going to hit Cancel because I didn't change anything. And then there's also another button down here at the bottom. I'm having a little issue with mine, so I'll drag this up, and then you could see this down here. You've got these checkboxes as well to display in process stock and transparent stock. So I have those turned on. I'll maximize my screen again. All right, so previously, before we had this preview, let's see, looks like we have a question here from Stuart Duncan. With Continue Rest Machining, it works great for secondary op, but let me scroll because I can't see the whole thing. Thanks, Brad. With Continue Rest Machining, it works great for secondary op, but I can't get it to work for third op. Great question. We'll try to get to that if we have time. Stuart, thank you for that. Okay, so previously, if you wanted to carry stock over, you'd have to run a simulation and hit play, let it run all the way through to the end. And then the old way of doing things is, it was a little bit of a workaround. So we'll let this run all the way through. So I'm just speeding through that. All right. And then when you got to the end of that operation, you would right mouse click, you would come here to stock, you would say save stock, you'd save it as an STL. And then what you need to do when you save that as an STL, you'd come to design, and then you'd come here to insert mesh. Then you'd say insert mesh, you'd navigate to that and drop in that stock as an STL, like one of these guys here from a previous time that I've done this. And then in your setup, so you'd bring it in, and obviously that stock was here. So I had to manually move it over here because we didn't have an automated way to carry it from here. Because when I created that mesh or STL, that stock, it was here. So I had to move it over here, make sure it was in the right spot, do some manual work to get it there. And then in the manufacturing side of things, when I did my second operation setup, so let's turn that guy on, and just for some housekeeping, we'll just expose that. If I right mouse click, edit, when you were here under stock, you would navigate here, do from a solid, and then here where it's blue, you'd navigate to that mesh. And that's up here. And there it is, and then that's how you would get the stock. And then you could start creating your toolpath through there. So it worked, but it was, there were some steps to get there. What we have now with that continue rest machining, what you can do, let me just shrink this here, is going back to the first operation. So once you run it through, it will keep track of the stock. So let's say I step through some of these operations that I've done, and you could see my cutting tools going through this part, and I'll just kind of speed through this. When it's done, that's what the stock looks like, that green body, and it captures that for us. So then now, when you get into the second operation, and we edit that, under stock, instead of from solid, or if you were to define the sizes, you just go here, from preceding setup, and turn on continue rest machining, and you hit OK. Now I'm getting this notification because of the way things are set up right now. I'm just going to say yes. I want to ignore that. I'm going to hit OK. And I'm going to just regenerate all of this. Let that calculate in the background. And then now we've got our stock there. It carried it over from this operation. And it looks at the origin of this main part, and it sets that stock relative to that based on the assembly instance. And it does a good job of handling that in the background. So it makes your life a whole lot easier. So again, this is that part. Let me switch my screen here. Where's my button here? Face. Okay, here. So when I'm done with that first operation, this is what that stock looked like. And then I took that and I flipped it over and I held it into a vise with this shape cut out in the soft jaws, and then I held it there, and then I carried on with the second operation. So the way we have it now, it's super easy workflow. Fusion handles it all in the background for us. So it was quite tedious in the past, but now it's good. And there's still some kinks to work out, but make sure you give that a shot. So, and then as I step through it will update each operation. So as I'm creating my toolpath, I can see what it looks like. So it does a really good job. And I can step through here, and I'm not gonna go through everything, but what I wanted to do is just kind of talk through that and share with you guys one of the workflows that I've used for secondary operations. Maybe what I'll do is I'll go through how did I program this, just like Brad did. Brad did his live stream a couple weeks back on how would you make that. I know that Brad's topic was how do you design it, how do you model it. So there were some questions. Some people were thinking, oh, they thought he would be actually physically making that part, like machining it. So what I'm going to do in a future live stream, Brad and I talked about this, I'm going to actually machine that part that Brad did. So look for that in a future live stream. Okay, so what I wanted to then go over, because this is pretty common where you have the first operation and the secondary operation, you flip it over and you put in some soft jaws. That's pretty well known. But then what if you have a part that looks something like this? This is a motor housing. I just mocked it up and designed it. And how would you go about machining this, and how would you hold it? What should you do for the first operation? What should you do for the second operation? And depending on who you ask, you'll get a different answer. Just like asking for directions to get from point A to point B, depending on who you ask, you'll get different answer. Some will be similar, but may not be exact. All right. So it looks like Brad might have been trying to send me something. All good. Okay. So how would I go about machining this part? So as I'm looking at this as a machinist, I'm thinking, how would I hold it? And what operation would I do first? Would I do this side first and this pocket? Or would I do this side first and machine this step and machine around here? If I do that, how would I hold it? And then again, I need to take into account the size of the part. So one easy way that I use is I'll just hop right into the manufacturing workspace. And I already had programmed this, but I'm just going to do a brand new setup. So if I do a new setup, and I'm going to set my orientation, select my Z. I will obviously, I don't want my Z in this orientation, so I will pick Z on this face, so Z is pointing up. And then my body is automatically selected, yes. But what I wanted to show is here under stock. Instead of preceding setup, I can do relative size box. And then when I come into here, Fusion will automatically add stock to the sides and top and bottom. So let me just put 100 thousandths of an inch, 0.1 on the top. And on the bottom, sure, 0.1. I can also then round up. This is a pretty handy way to quickly come up, instead of using the inspect tool and do some measurements. By doing this, I know right away I need a piece that's 12 inches by 11 inches by 2 inches. So that gives me one way. I could also come here to fixed size, but I'm going to do relative, and then here you can do no additional. And then don't worry about that, and then it will give you these sizes, but then again, you don't get that rounding. So you can do add stock here and do some number here, whatever makes sense. Obviously, if you're in metric, you might have a different value there. But now I have an idea of the size of this. So then I need to think, okay, well, if I hold it like this, and I have a vise that's maybe clamping here and here, that could be doable for the first operation. And then if I machine this side and I have that, how would I flip it over for secondary op? Would I grab on that? Would I have to make some big soft jaws? Well, what I'm going to do for this part here, I'm going to machine this side first, this cavity and this face. And then I'm also looking at these, there's some threaded holes here, and there's a dowel pin hole there and there. So I'm actually going to use those features that are built into the part for my second operation to hold the part. So let's dive in, and we'll start talking about what I mean. So I'm just going to cancel this setup. I'm going to go back to the design workspace, and I'm going to expose what I did. So I created a fixture plate for this second operation, and we're going to talk about that. And once you start seeing this, you will see what I mean. So again, imagine as if this is machined from this side. And what I'm already envisioning is machining this pocket, machining this face, machining around this contour around the outside, and doing the drilling and tapping, threading of these holes, and then those reamed holes. Then once I have all of that established, I could flip it over and bolt it to this fixture plate, and I can hold it with some fasteners, some socket head cap screws that I put in there. So let me do a section analysis so you can see what I mean. So as I drag this in like that, you can see, whoops, that's turned off. You can see that I've got the part, and I've got this fixture plate with some socket head cap screws, and that's being threaded into the part. I also have, let me do another section analysis, perhaps on this face, and I want to intersect where that reamed hole is. So I'll say okay. So that pink part there, that's going to be a dowel pin that's pressed into this fixture and into the part. So now if I hide the part itself and I turn off the analysis, you can see we've got the aluminum plate, or it could be steel, and then I've got these socket head cap screws coming through the bottom, and then I've got the dowel pin holes with some pins pressed in there, and those those pins will go right into the part. Obviously, you'd have to figure out what tolerances you need based on the application. Depends on the application and what you're doing. But so that's how I'm going to hold this for the secondary op. And then now, when I'm clamping it this way and I'm holding it down and I machine it, it's securely fastened to this plate. And instead of, if I didn't have this and if I was squeezing on it with the vise, then I can get some distortion or the part squishing in that axis where the vise would be grabbing. So this is one way that you can do it. It works well for thin wall parts, and to prevent your part from being distorted. So what we'll do now is we'll go through the process of programming this part here. I'm going to take a quick look at the chat just to see if there are any questions. So let me look over there. I got it on my screen here. Okay, Brad doesn't have anything in the one that we're doing. Okay, thanks, Brad. No questions. Cool. All right, guys, I will switch back to my Fusion screen. All right. So let's come in here to manufacture, and let's go through the process of machining this part. And I'm going to start from scratch. So I'll go to setup, create a new setup. Very first thing I want to do is make sure I'm in milling, set my orientation. I don't want model orientation. I'm going to select my Z. So I'm going to select my Z normal. Let's say this face. And then my X can go in this long direction. I'm fine with that. And then remember what I talked about before? The X, Y, Z are red, green, blue, or RGB. So those are some ways to remember. Sometimes you'll get these colors without the letter. So like here on this origin, you see the red, green, blue, and that's on the model orientation. That's separate from the WCS that we're doing in manufacturing. So you'll notice this triad here is different than that. That's the model design. This is our CAM work coordinate system. Okay. So I will then verify the body selected for op 1. Here under stock, I will say relative size box. And let me just add some material here. So on the sides, I'll put 0.1. On the top, I'll do 50 thousandths, and on the bottom I will do, let's grab onto a 1/4 inch. All right, so that's good. Post-process, we've talked about this before. This is just a program number, and then we'll call this op1. WCS offset number 1 would equal G54, or the first work offset of the post processor that you are using. I see a question came through. In this example, how would you pick up G54 for the second op? Great question. I will talk about that when we get there. All right, Stuart, good question. Thanks, Brad, for letting me know. So I will OK this. So now, Fusion's thinking a little bit. All right, so I'm going to come in here. I'm going to rename this. Let's call that op1. Don't disregard the ones up there. Okay. So very first thing I want to do, I want to start roughing this guy. I'll see a lot of times people will face first. And I'm not a huge fan of that, because if I face this part, let me show you what I mean. If I face this part, and I'll just pick this tool, and I just say OK. So look what happens if I run simulation. That's fine if I mill that and I face that. But a lot of that is going to be wasted cutting time. So on a part like this, I would not face it first. So I'm going to delete that facing operation. And I'm going to start with an adaptive clearing. That's under the 3D adaptive clearing. I'm going to use this 3/4 inch bull nose end mill. And that's about a 19 millimeter tool. All right, so here under geometry, I will leave those as default. My source is the setup stock. And what I wanted to go to is on the heights. By default, it says model bottom. So if I look at it from the front, it's going to that blue line. I do want to go below that a little bit. Actually, I don't, but I do want to hit this pocket all the way down. So let me just give, you know what, that will be fine if I leave that 0. Passes, I'm going to leave it at all my previously set defaults. The ones to pay attention to are optimal load, and that's the sideways engagement, the radial engagement. I use a formula. I right mouse click, I edit the expression. So right now it's set to 40% of my tool diameter. I can change that, but I'm just going to leave it at 40%. The other thing I also do that I set, pro tip for you guys under maximum roughing step down, I don't type in a number here. I also have an expression, and I have it tool flute length times 0.95. So what you can do, you just start typing all lowercase, tool flute, whoops. So what you can do, if you don't know all of these, you can come into here and start scrolling down. Aha, look, so there's the tool underscore flute length. So Fusion will filter it for you. Then you can do something like times 0.9 if you wanted to, times 0.9, and hit OK. And then now my maximum roughing step down will be 90% of my tool. And I can right mouse click and say, make that my default. So now anytime I use this adaptive strategy, it will give me that roughing step down a percentage of my tool flute length. Makes things super easy. If I change my tool, I don't have to go back and remember all of this. It's parametric. Some other things I do like to turn on is turn on smoothing. And then I right mouse click here, edit that expression, and I just make my smoothing equal the tolerance. I will right mouse click and say make default. Some other things on linking here, I like to give it a ramp taper angle, and another one to pay attention to is the minimum ramp diameter. If I edit my expression, I have helical ramp diameter times 0.25. What that controls is, let's say you have a pocket or a cavity, and right now this value is 0.655. That's a percentage of my tool diameter. If I have a small hole or a small pocket, if that pocket is smaller than this number, your tool won't enter. So I get this a lot where people say, hey, why isn't my tool entering this pocket or in this slot? Well, that's why. So make sure your minimum ramp diameter allows your tool to get in there. A couple other things to pay attention to is when the tool is repositioned, this is the feed rate it's going to go. So you can do something fast, whatever the maximum feed rate is on your machine. It varies from machine to machine. Verify that, what your maximum feed rate is. That will speed things up. So now when I hit OK, Infusion generates the toolpath. So all of these yellow, there's some other linking moves that I could have told it to minimize some of those retracts. Let me go in there really quick here. And under linking, this maximum stay down distance, if you make that number bigger, so remember our part was about 12 inches. What if I do put 12 inches here? Now watch what will happen. Fusion's recalculating. And we've got some stay downs here. And so that feed rate is going to be going at that maximum feed rate, that 800 inches I put in there. And there's one other setting here under stay down level. All of us Autodeskers, we like to use 70 to 80%. It will increase the calculation time, but it gives a nice smooth transitions and a nice smooth toolpath. So we'll give that a minute to calculate. Now you can see the tool is staying down here instead of going from here, lifting up and retracting. So you get a smoother toolpath. All right, so next we've got this part now, and this is what it looks like. So what we need to do now is finish that pocket. We need to face it. Remember how I told you I wouldn't face it? So now what we can do, I'll give you two strategies here. If I do facing, I could use that same tool, and if I just say face with that tool, this is what you'll get. You could further dial some things in. You can go here under stock contours. What happens if I grab those two? You'll get something like that. But then when you actually cosmetically and look at your part, you'll have these lines that are going like that. Another thing that I like to do sometimes is I'll use a 2D contour. And so I'll take the 2D contour. I'll use the same tool. And under geometry, let me grab this edge here. And I've talked about this before. When you change something, you get this red arrow. The red arrow shows the side of the contour that the tool will be on. But we actually want the tool to be on this face here. So I'm going to hit this red arrow there. So now watch what happens if I just hit OK. I'm not going to do any other settings. Our toolpath will look like this. So let me do a quick simulation and run this. So look here, when the tool is going here, it's not going to hit this little edge. But what I wanted to just show you is the tool will kind of follow that inner edge. So how do we get that to clean up? So first of all, I need to get rid of this facing operation. I'm going to delete that one. And then on this contouring op, what we need to do is under passes here, we can give it a stock to leave. And on the radial stock to leave, I'm going to give it something like -0.1. And then axial, I'm going to make that 0 because we want the tool to touch this face. But now watch what happens when I run this toolpath. So now the edge of the tool is 100 thousandths beyond that edge. So as it's milling, but we still have this little area here, that little guy right there that it's not getting. How do we control that? You can come into here like this. Couple ways to do it. You can go under passes. You can do multiple finishing. And I can do something like, what if I do this? 5 passes at ½ inch. Look what we get. Okay, so that will That will get the whole part. But then again, we have all this wasted space, wasted cutting, air cutting. How can we handle that? Some of my colleagues do this. My good buddy Devin, he uses this. It works really good. So what you can do is come into here under geometry. You can tell it stock contours and chain this outer edge. So now it will say, okay, there's where my material lies inside that yellow line. So even though I told it 5 passes, now watch what it's going to do. It will trim automatically so that it actually cuts what it needs to cut. So now we don't have that little lip that was here and here. So that's so now if we don't even need to run simulation because we've got this stock turned on, but you can kind of see what it looks like. It's nice and flat up there, and you'll get a nice even looking toolpath. All right, so let's carry on and move on with the next operation. I want to mill around the outside of this part. So again, I will take this 2D contour. I'll use the same tool, and I'll just grab this edge here. And tool is on this side of that cut, and it's going in this direction here, in a clockwise direction. And under heights, you'll notice that I picked the bottom edge instead of the top edge. Why did I do that? Because on a 2D contour, the default depth, or the bottom height, goes from the selected contour. So if I selected the top edge, I would then need to give it some additional values here. And I still do, because I did grab that bottom edge. So I can come in here and say, go minus 50 thousandths below that. And now, watch my toolpath. If I come here, now my tool will come below that edge and mill around that contour. So we're making some progress here. We've got the inside roughed out. We finished the top. We finished around. Now let's finish this inside. So what I'm going to use for that is just a standard 2D pocket. And there's a couple ways. You can grab the floor or you can grab the edge. It depends on if you have features in here like a hole. Then you would grab this edge here. And what Fusion does now, it gives me that blue preview of where it sees material. This is going to be obviously the edge that it's going to mill around, and it's going to remove all this material here. One thing to pay attention to, so again on the heights, on the depth, it's going to that selected contour. I selected that floor. Under passes, so by default, radial and axial stock to leave is turned on. Since I already roughed this, I do want to use this pocketing operation as a finishing op. I'll uncheck that. And then let's hit OK, see what we get. So now, tool will start here. It's going to spiral down and mill this bottom floor and finish that wall. But this is kind of, I'm not a fan of this. See how this helix, how it's starting at the top? We can fix that so we don't waste as much time starting so high. So on the heights, there's a couple of things you can do. Here under feed height, you can disable that. And then under the top height, instead of coming from the top of the stock, you can go from a, actually I can do from the selected contour and say, let's start 100 thousandths above the selected contour. And let's see what we get. So now it's going to wrap it down. I'll always be mindful of what material you have down in there. But see, this is going to save us some time. Instead of starting above the part and how it was starting up here and spiraling all the way down, now it's going to wrap it down and then it's going to engage from down here. So that's just a little pro tip there to save you some machining time. All right, thanks Brad for manning the chat. All right, I see we're quickly running out of time like Brad and I tend to do. These hours go quickly. All right, so next what we're going to do is, so we did the roughing, we faced it using a contouring op, we milled around the outside to finish that wall, and then this is going to finish the pocket. So what we can do now is start working on some of these holes. So let's come into here, and I'm going to do drill. Let me grab a spot drill. Let me come into here and look for my spot drill. I'm going to use this 1/2-inch spot drill under geometry. So there's many ways that you can do these holes. So one way is you can grab the cone like that on a spot drill. So I want to go hit that hole, and I want to hit this hole, and then I'm just going to hit select same diameter so that it goes and finds all of them for us. And if I look at it from the front, you can see that the Z depth, it's obeying the Z depth based on that chamfer, the modeled chamfer. So it's pretty easy to do. Under cycle, instead of a drilling wrap it out cycle, that would output a G81 on most controls. I'm going to do the counter boring, which would give you a G82 with a dwell at the bottom. So I've talked about this before. Let me, so if you think about when you're countersinking or counter boring, think of if you're on a Bridgeport mill or on a drill press. When you're pulling that handle down and the drill goes down into the hole and you're pulling down and you sit there and you hold it down to allow the tool to spin a few times, CNC machine is the same. It's always thinking ahead. So if you tell it to go down and then the next move is to wrap it out, I like to give it a dwell, the G82, so that when it gets to the bottom, it pauses there for a second. You can nerd out and give it some math based on the RPM and divide it by some numbers to get you to do two full revolutions or whatever you want to do to calculate that. But so that's what I do. Let the tool come down and then sit there for just a moment to get a couple good revolutions to make that bottom, the counter bore or the counter sink, perfect and nice and shiny. Pro tip for you guys. So that's why I use the counter boring with a dwell, just to save time. I'm not going to worry about doing any calculations there. I'll just dwell for 1/3 of a second, and I'm going to hit OK. Okay, so Brad says, when I did the 3D adaptive, there's a question here. When I did the 3D adaptive, why does your spiral ramp have a taper? Great question. So this guy here, that's what Brad's talking about. So if you look at that red, there's a slight taper. So where does it get that? Here under linking, I have this ramp taper angle. I currently have it set to 3 degrees. So let's run the simulation. If we simulate this, and let's get to the part where it's actually in the pocket. Give it a moment here. There it is. So as the tool is going deeper and deeper, let me slow this down a little bit. Hopefully the graphics are representing. So as this tool is spiraling down deep into the pocket, if you give it a taper angle, what happens is here, I'm going to zoom in as much as I can. You have this little clearance here because as it's going deeper and deeper, there's this little gap for the chips to evacuate and for the chips to come out. And you'll really notice this at your machine tool. So if you didn't have that and the flute of this end mill was rubbing on this wall, you'd hear like the chips gargling down in that pocket, in that cavity, as the end mill is recutting chips and recutting chips. So by introducing that slight taper angle on the entry, it makes it a very, very smooth cut at your machine. It sounds good. It's just better for your cutting tool. So I highly recommend turning that on. Great question. All right, so we'll let this guy finish. Actually, we'll carry on. So we did the spot drill. Now we need to drill and tap these holes and then drill and ream. And we got to quickly flip it over. All right, so let's do another drilling operation. Let's grab, so that's a M10 by 1.5. So I need, where's my 8.5 millimeter drill? That's a tap drill size for that. So for those of you that don't know, it's the diameter minus the pitch. So it's an M10 by 1.5. So the pitch is 1.5, so that's the drill size. It's 1.5 less than 10, which gives us the 8.5. All right, so you don't have to look at any charts. Obviously, if you have a roll tap, it'd be a different story. I'm talking about cutting tap. Okay, so let's grab this tool. Again, more than one way to do this. I'm going to keep with tradition, how we've been doing things. And I selected that face, select same diameter. Again, if you ask 10 people, they'll give you different answers, how they prefer things. I'll just do it like this for now. Under heights. Fusion's looking at that inside cylinder, and it's going to give us a preview. I do want my drill tip. So let me come into here like that. So I do want that drill to break through that back edge. And I'm going to give it a big value here because I also still need to tap it. So let's give it maybe a 1/2 inch. So I'm going to drill it. I'm going to drill it like that because I still need to tap that. And here under cycle, drilling would give us a G81. You can do a G73, which is the chip breaking with the partial retract. Sure, we'll go with that for today. Hit OK. So now you can see we've got our transparent stock, and you can see things taking shape. So now we need to tap this. A couple ways to handle this. One way, instead of going back through and reselecting everything, you can right mouse click and you can create a derived operation from the highlighted operation. So I've got this drilling op. I can say I want to drill, and then now I'm going to pick that tap. So I need to navigate to this setup here and find my tap. There's my M10 by 1.5 tap. I'm going to grab that. And it retained, you know, all of these, the whole bottom, drill tip through. So instead of going a 1/2 inch below, I'm just going to do a 1/4 inch below. So the tap doesn't go quite as deep as the drill, so it doesn't bottom out and break. And then under cycle, I'm going to verify that that's a tapping, okay? No dwell, I'll hit OK. Next, I need to drill and ream these 2 holes. So let's come in and do a drilling operation. We'll grab our tool, that's a 6mm dowel pin. And I'm going to grab, where's my small drill that I had? A 5.8mm drill. Under geometry, let's grab this cylinder, select same diameter. Under heights, I'll break through that by, let's use that, let's do 0.300, so I'm breaking through. Hit OK. So there's that drill, and then now we need to ream it. So we'll do create derived, drill again. This time I'm going to select the reamer right here. All right, 6mm reamer. Obviously, depending on your slip fit or press fit, you would accommodate for that. I'm not going to worry about that right now. And under my heights, I will just do something like that, break through by 100 thousandths, so the reamer doesn't go to the bottom of the hole. Under cycle, a couple things you can do. You can do drilling. We have some other options here, but I'll just leave it here and hit OK. All right, nice. So we've got this side pretty much done. We do need to throw a quick 2D chamfer to break the edges. So let's grab, I have a chamfer mill here. I have a 1/4 inch helical tool, and I'll select that one. And then I'm just going to grab this edge and this edge. Let's go to my passes. I'm going to say, just give me a nice little corner break. And we've talked about this tip offset before. Let's make that 70 thousandths and chamfer clearance. So now we'll mill around and deburr that. And now we're good. Do a quick save in case something happens. So op 1 is done. So now we need to quickly flip over. Let me take a look and see if there's any questions. Brad, thank you for manning the chat. Okay. Now we need to define our op 2. So let's make a new setup. And I'm going to pick my orientation. This time, my Z is going to be normal to that. And then my X can be this direction. If I wanted it to be sitting in my machine this way, we can also do that. Now there was a question that Stuart Duncan was asking about how do you pick up the G54? So great question. Couple ways you can do it. So let's go ahead and define. So there's our model. We also need to define our fixture, which was up here. Come over here, we'll navigate to that fixture plate. And I'll also put the fasteners in there. So now we'll have some visibility of that. So there's a couple ways that you could handle, and I forgot to do a setting here. Let's go back. We hit this side, but here under stock, we need to verify it says from preceding setup, and then turn on continue rest machining. Post processor, we will do 1, 2, 3, 4. I don't care about the program number, and this can be op2. And instead of doing G54, we'll do G55. Okay. So now you'll see we have that stock already defined. It's that green. You can see where the holes were and all of that. And so now we can start machining from here. Couple ways to go about this guy, but let's quickly talk about, let me see, can I hide this part? And let me go back into my design. Let me hide this. And so Stuart, there's some things you can do. Obviously, if you machine this all in one, you could pick up the edge. But what I like to do, so one way you can pick up that, you can pick up this hole or that pin. You can probe that pin. You can indicate that pin. Obviously, you need to make sure that this face is parallel to your X. And the other thing that I do, sometimes I'll actually machine a hole or a pocket in here, like say a 1-inch diameter or a 25mm diameter bore, so that when your part is on there, let's say you got a hole right here, you can just probe that bore. You can hit the Z face with the probe, and you can probe that bore, and that's how you can get your reference for your 0 offset. And then when you come to the manufacturing side on your setup, what I can do here is under my origin, I can do selected point, and let's grab that. So let's say that is my 0 point. So that would be my, in this case that we're doing is a G55 0 offset would come from there. And again, like I said, if you had a hole here, you could pick that. You can pick a corner, it doesn't matter. So like here, I can grab that point and say that's my 0. But what I would probably lean towards is come off of, whoops. I was, when you select this here, and keep in mind, and this gets people a lot, if you're selecting your Z, it'll then toggle or jump to the X selection. So be mindful of that. That you don't think you're on your WCS or your Z. Be mindful of that once you select the Z, it will automatically jump asking you what's your X, okay? So let's say our origin is going to be this pin, and that looks good. I'm going to hit OK. Hopefully that answers Stuart's question. All right. So now let's start machining. I will just take, just to save some time, I'll use that same tool. This tool number 2. And for my geometry, I will leave that here. Rest machining from my setup stock. Under heights. Now, this face, remember, that's already machined. So instead of going to the model bottom, I can do a selection and click on this face, and I can say stay away from that, but I already can control that here in stock to leave. Stay 0.02 inches away radially and axially. So I'll hit OK. and let Fusion do its thing. It will start machining and roughing this part. And so that looks pretty good. Depending on how much stock we had here, I may omit this, but I'm just going to leave this for now. So now we've got this roughed out, and now we need to finish this. So a couple of things that we can do. Obviously, we've got our facing. We can face this top. I don't even need to really select anything. Let's hit OK. If I don't select anything, we're going to get some air cutting. Remember how I talked about here under geometry, under stock contours, instead of looking at the yellow rectangle of the outer edge of the stock, I can grab this. So then now the toolpath trims a little bit better, and this will be fine for this application. Next, I want to do a 2D contour, and I'm going to hit this bottom edge. Again, I'm selecting that edge. What happens if I hit OK? So now we're getting a very similar behavior as a tool comes through here. We're getting this little step there. You see that? Because the tool doesn't quite clean up all the way to that. So how can we handle that? Couple ways. One way, you can come here under passes. You can give it roughing passes. And I can say 2 passes at a certain value. I can right mouse click, edit that expression. So it's basically 95% of the tool diameter. It is taking into account the corner radius, but I'm going to do 75%. And I'm doing 2 step overs at this value. And then now look what we get. So now the tool, oh, there's one other setting. Let's jump back over here under passes. This step over here. Let's do 15 thousandths. Okay, so now it'll come here, but again, we're getting some air cutting. So how do we trim that? Remember, we just talked about that on the op1. If we come into here under under geometry, I can go to stock contours and say, click the wrong thing. Okay. So now our stock is going to follow that boundary, and it will automatically trim and handle that for us. So again, like I said, my buddy Devin, he uses that, and I like using that. It's a good tip. All right. So we roughed it, we faced it, and we contoured this face. So that's about it. Obviously, we can run the chamfer tool on here. Let's come into here. We can do a 2D chamfer, and I will grab some geometry. I'll do this guy here and this guy here, and I'm not going to worry about anything else. Actually, I will. Let's just do a small corner break, 10 thousandths, and let's leave all that how it is. And there we go. So now we've chamfered that, and we are good to go. Then obviously when you're done with the part, you would simply unbolt it from the fixture and you're done. Whoa, and we finished before the top of the hour. That never happens, that we finish before the top of the hour. Kind of breezed through it. I hope I didn't miss anything. Are there any other questions? Looks like there's no questions. We got 110 people watching. Thank you, everyone, for being part of this live stream today. We appreciate you. We know you're busy making parts, learning Fusion, all that good stuff. So looks like there are no further questions. Brad will be up next Thursday, same time, continuing his series on that saw stand that he's working on. I am going to take one last peek at the chat. No, all good. Any questions, drop them in there. We'll do our best to answer them. And thank you for spending part of your day with us. We appreciate you, and we'll see you next time.